Hi, my name is Amit.
Hi, I'm Sindhuja. We both worked on the Geo Controller. So Geo Controller consists of a compass and GPS.
The GPS module gives us our current position, latitude and longitude values, and we are getting our checkpoint latitude and longitude values from the Android app. And considering both latitude and longitude values, we are calculating distance and bearing values.
So the compass actually gives the direction. The direction is basically the heading value in which the car needs to travel. So let's look in detail into the hardware of it.
Here GPS is connected to the SJ1 board through UART, and in the GPS we also need to attach antenna. Without antenna we will not be getting any lock on the satellite.
So basically when we get a lock, this will start blinking. Now compass is connected to the SJ1 board through the I2C communication. Here compass needs to be mounted horizontally because if there is a tilt, then the values might change drastically. Now coming to the onboard facilities which we used, we used the 7-segment display as well as the LEDs to indicate certain things.
7-segment display will tell us the current turn angle that we are sending into master. First LED will glow when we have successfully interfaced with the compass. Second LED shows us we are constantly getting readings from the compass. Third LED will glow when we will toggle when we receive checkpoints from the Android. And fourth LED is for the CAN transmission part.
Basically this turn angle will become 0, and that indicates we have reached the destination. We are going in the right direction, as well as when the distance becomes 0, we have reached the destination. So for more details about the Geo module, please look into the report in Wiki.
Thank you.
Hi, this is Bhupendra. I am working on sensor controller. The sensor controller consists of 4 sensors connected to the SJ1 board. 4 sensors are like, one front sensor is LV Max Botic MB1010 and rest 3 are HC-SR04 ultrasonic sensors. All the 4 sensors are connected to port 2 of SJ1 board. LV Max Botic MB1010 has range of 600 centimeters, while the rest have a maximum range of 500 centimeters. This is the sonar sensor, rest are ultrasonic sensors. The triggering is done in pairs, front back is one pair, another is right and left. The first trigger is given to front and back, after which we wait for a 50 milliseconds delay. Then we process the distance calculation using the interrupt subroutines, and then we trigger the next sensor, right and left. So this happens in cycle, and all this processing is done in 10 Hertz. All the sensor calculations, distance generation and transmission on a CAN bus happens at a frequency of 10 Hertz. So on the display we can see that we have displayed the front sensor readings on the LED display. As you can see, I am moving my hand over here. The front distance is divided by 10 and displayed on the LED display. The fourth LED indicates that CAN transmission is successful. Thank you.
We are the Android team. I am Asmita Deshpande.
I am Akshay Kanchar.
As a part of hardware design, we have Bluetooth module SC05 which is connected to the SJ1 board through UART. We are using UART 3. As an example of used case, we have these 2 buttons on our Android app, Car Connect and Map Navigation. Our Bluetooth module SC05 gets connected to the Android phone when we click on the button Car Connect, and when we click on the Scan Devices button, our module gets searched. When we click on Map Navigation button, here we can see the Google Maps and we get source from Geo module. Then our app calculates the number of checkpoints and sends over to the CAN bus to the Geo module.
So, as part of the additional features, we have the kill button on the Android app. So when you send kill button, it will send a signal to master which will reset all the boards. The third button we have is the reset map. So reset map basically clears all the checkpoints which are currently on the map. Additionally, it also resets the geo checkpoints. Thus the user can set the destination multiple times. Thank you.
Hi, this is Gaurav Chaudhary and I'm working on the master controller. This one is the master controller, and basically the master controller controls the motion of car. It retrieves the data from sensor controller, Geo Controller, and provides whatever decision is made to the motor controller. And at the initial of car movement, it receives start command from Android, and this is how the master controller provides data to the motor controller. Also, we have implemented boot messages and boot functionality. What it does, it initially sends boot requests to all the controllers, and when they are sending the boot replies, then the boot status is sent to all controllers that everything is working fine, it can move ahead. So other than this, we have implemented a huge algorithm for obstacle avoidance, and it retrieves 4 sensor data from the sensor controller, and this is how decisions are made whether to go front, left, right, and reverse. It depends on the readings from the sensor controller. Also, we have implemented a Geo algorithm. The Geo algorithm is decided based on the movement of car, like the tilt angle and the direction where to move, left or right. Now I'll describe you about the hardware. We have not much hardware in the master controller, but we have implemented the LED display and all the 4 LEDs. It signifies something. This one is the LED display. It is showing 0 now because it has received all the boot replies from all the controllers. If I am resetting it, it will retrieve all the boot replies. So now the 0. Next, these 4 LEDs show the sensor data from all the 4 sensors, where the movement is. If the right one is blocked, the first and the second one. The second one shows the left, front. First one shows the front. So if the right one is blocked, the first 2 will blink, and similarly all the 4 will show some data. And also we have implemented here as a kill button. So if I am pressing, all the controllers will be resetting, and all the boot thing will start again, and again the processing will start. And this is how the master controller is doing its processing. That's it from the master controller. Thank you.
I'm Sudhir. I'm going to explain the MotorIO Controller in brief. Basically, the MotorIO Controller, it receives commands from the master, and then it drives the motors. Basically, we have 2 motors, one for the direction control, that is the servo motor which is in the front, and the other one is a brush DC motor which controls the speed levels and the forward and reverse movement of the car. Going into details, both the motors, they operate at a frequency of 100 Hz, and then their operating duty cycle is between 10% and 20%. So from 10 to 15, the servo motor will be like it's moving towards the left, and from 15 to 20 it will be towards the right, and 15 it will be at rest. It doesn't turn at all. And similarly, the DC motor, it turns forward from 15 to 20, and then reverse from 10 to 15. Getting in closer to the controller, we have 4 LEDs over here. These LEDs indicate the heartbeat message and the communication activeness and stuff like that. And coming to the I/O display, this gathers information from the Geo Controller, the sensors and all, and it displays in 4x20 display, character display, and you can see the values here: the front sensor, left sensor, right sensor, and then back sensor. And it also displays the checkpoint distance and the final distance. Okay, that's it. Thank you.